Welcome back. So in the previous topic or in the previous video, we were discussing about the introduction and how the cylindrical pressure inside the vessel, what we have discussed. So in this topic, what we're going to discuss is about a circumferential stress or a hoop stress, how it will be developed inside in a cylinders, how the pressure or in a circumferential stress or what we call as a hoop stress, how it will be developed inside the cylinder. So that we're going to discuss or that we're going to see in this particular video. Yes, the circumferential stress are in a what we call it as a hoop stress. So considering you can able to see this is a diagram where we have taken a view of that particular cylinder where you can able to see this two diagrams what we can able to see that is nothing but an where we have what we have considered as an one of the views how the pressure will be distributed inside the cylinder and along with the x-axis and how it can able to split up through this sectional views. So only we have been considered as an sectional views for this derivation. So circumferential stress or what we call it as a hoop stress. So consider a thin cylindrical shell subjected to an internal pressure as shown in this particular figure where you can able to see this is an closed vessel. So just we have taken as a sectional view. One this is an front view and this is an a top view of that particular cylindrical shell where the cylinder is subjected to an internal pressure. So how the internal pressure is created? So the internal pressure is nothing but whenever we are going to compress or we are going to fill with any closed vessel, automatically some pressure, internal pressure will be created because we are not going to apply any load externally on this particular cylinders because of the compression or because of a filling of an like liquid or on a gas or any thing which is inside the cylinders that create or that exerts an internal pressure. So the internal pressure, whenever the what happens when the internal pressure is created, automatically the cylinder has to withstand or it the pressure will inside the cylinder, the pressure will be more because of the what liquid or a gas which has been filled that has been created in a more pressure. So at that time what happens, the cylinder has to has a tendency to split into the two or off along the section, means it will not come out from the cylinder but along in that cylinder only whenever the internal pressure is more it starts along with the inside the section but it splits along with the inside the section only where you can able to see this is an a P is nothing but an a pressure where it has been created and what the sigma notation what we have been consider is as an circumferential stress or what we call it as an hoop stress, and T is nothing but an a thickness and where L is nothing but an a length of that particular cylinder. So this is what about a brief explanation or a brief diagram that what indicates is nothing but a sectional view of that particular cylinder what we have been or a closed vessel what we have been considered. Let L is nothing but a length of the cylinder and T is nothing but a wall thickness of shell and where D is nothing but an internal diameter of shell and P is intensity of internal pressure or what we call it as a sigma C or what we call it as a sigma 1 is nothing but a circumferential or a hoop stress. See where L is normally the length and the thickness. So the thickness of the shell is very important. Why the thickness of the shell is important is nothing but based on the thickness the diameter what is there, based on that only the thickness will be there on the shell. So the thickness, the main thing in the thickness is nothing but where it can able to withstand the internal pressure which is created by the liquid or a gas inside the cylinder. So it has to withstand that tensile load, right? So within that permissible limit only it can able to withstand or it should withstand all the pressure which is acting inside the cylinder. And D is nothing but an very internal diameter and P is the what is the intensity of the pressure, how much the pressure has been created and what will be the permissible limit on that particular cylinder, how it can able to withstand. And the sigma C is nothing but a circumferential or a hoop stress. Now bursting will take place along the section XX where you can able to see in this particular direction we can able to consider as an X axis. So whenever the more pressure is there, the bursting of the will takes place inside the cylinder along with the X axis if the force is due to if the force due to fluid pressure is more than the resisting. See what happens for always whenever we're going to design or manufacture any component we're going to give some factor of safety or resisting capacity. For example, if we consider any material there will be having some maximum limit of that withstanding capacity of that particular material. If it is crosses more than that, automatically there is a damage or a failure of the material will takes place. So similarly here what happens, the bursting will takes place along the section XX if the force due to the fluid pressure is more than the resisting. If the pressure is more than the resisting force is nothing but a capacity of the shell inside the which is the shell we are going to use. The capacity of the cell is nothing but a resisting force. Due to that circumstantial stress is set up inside the material, whichever the material we are going to use in that, that will resist the power, or it can able to withstand the pressure which is creating from the fluid. So next one is nothing but we're going to consider the force due to circumstantial stress or in a resisting force along the x section, which we have been considered. And the how we going to consider that force is in the circumstantial stress is nothing but internal pressure, internal fluid pressure, which is the internal fluid pressure into the area on which the pressure is acting. Area is nothing but cross sectional area. We can able to consider along where we don't have any particular cross section, so we can able to measure is nothing but the PDL is nothing but where the P is nothing but a fluid internal pressure, and D is the diameter and along with the length. The diameter is nothing but an internal diameter of the cylinder along with the length. So now the internal fluid pressure will be the force due to the circumstantial stress will be equal to PDL. P is nothing but an internal fluid pressure into the diameter along with the length. So this is how we can able to identify the force on the force due to the circumstantial stress which is creating. Next one, force due to the circumstantial stress or a resisting force along the section x. So now force due to the circumstantial stress along the resisting force along with the xx. So now what we can able to consider is nothing but a circumstantial stress into the area on which the stress is acting. So in the previous we have considered as an to find out the force along with the internal pressure. Now we got a force. Now we need to find out the what is the circumstantial stress which is acting inside the cylindrical shell. So circumstantial stress into the area on which the stress is acting. So circumstantial stress how we can able to identify is nothing but notation we can take either sigma 1 or sigma c into T into L. T is nothing but the thickness of the shell along with the length plus T into thickness of the shell will be equal to 2. What happens? Two times of an thickness and along with the length into the circumstantial. This is what the notation what we got to find out the circumstantial stress. Now what happens for the when we apply an equilibrium condition? So the resisting force will be equal to the bursting force. So the resisting force is nothing but where the inside the cylindrical shell where the cylinder can able to withstand the force, and the bursting force is nothing but which is the pressure which is created because of an internal fluid pressure. So the resisting force is nothing but depends upon the material where the material or in a cylinder is designed in order to withstand the force, but the bursting force or the force which is created is because of the internal pressure which has been created there. So now what the resisting force what we got in the previous equation we can able to see that is 2 into times of thickness along with L into the circumstances, and what the force we got is nothing but an PDL. So now we are going to equate these two equations in order to find the circumstantial or in a hoop stress. Now by equating the in the equilibrium condition sigma 1, that is the circumstantial or hoop stress, what we got is nothing but PD by 2T. P is nothing but an internal or intensity of the fluid pressure, and where D is the diameter and 2 and T is nothing but a thickness. So this is the stresses which is acting inside the cylinder is nothing but a tensile stress. Tensile is nothing but it is elongating because of an internal pressure. The tensile stress is acting inside this cylinder. So this is the equation in order to find the circumstantial or an hoop stress in any cylindrical vessel is nothing but sigma 1 or sigma c will be equal to PD by 2T, and the stress is nothing but an which is acting is tensile stress. So this is how we can able to identify the hoop stress or any circumstantial stress in the thin cylindrical vessel. So thank you.